Let us learn on how to use determinant method to solve simultaneous equations of 3 unknowns. We are familiar with how to solve for 2 unknowns. Let's now implement it for 3 unknowns. Now, so we want to evaluate for x, you know the way we did earlier, y, and z, and there's a constant term. So we have determinants for each variable, determinant term for this, and likewise determinant term for this. So let's put z, let's put 1. So now we want to evaluate, what determinant is here, what are the variables here, and what are the variables here, likewise what are the variables here. So now pause the video now and give it a try. So for x term now, cover all of x and we left it 1 2 3 1 2 3 1 2 3. So that's b1 c1 and d1, b2 c2 and d2, b3 c3 and d3. Likewise for y, we duplicate all of y and then we are left with a1 c1 d1 down to 3, a1 c1 d1, a2 c2 d2, a3 c3 and d3. And for the z term, nullify these and we're left with a, b and d terms. So, okay, a1 b1 and d1, a2 b2 and d2, a3 b3 and d3. And finally for the constant term, nullify all of these and we are left with abc. So that's a1 b1 c1, a2 b2 c2 and a3 b3 and c3. Now with that being said, now in the previous video where we learned on using the determinant method to solve 2 unknowns, we saw how we implemented the place signs for this, where we say plus, minus, positive, negative, and the x. And since it was x, y, and the constant 1, so over z1 over z2 over z0. So we were like, okay, fine, let's use, so plus, okay, positive, negative, positive. So this one became negative y. All right, now we are going to apply that in this now. Okay, let me leave that. So let's apply that now and we'll say positive, that's the place sign, positive, negative, positive, negative. So therefore we say that this is positive x, negative y, positive z, and negative 1. So with that being done, for the place sign, we now have our answer, our expression to solve 3 unknowns, 3 equations using determinant method. So let me clean this and let's proceed. So to further simplify this now, we can say that everything here is equals to delta 0, delta 1, delta 2, and likewise delta 3. So we can now come to a conclusion of the expression of solving simultaneous equation of 3 unknowns and say this will be x divided by delta 1 is equals to minus 1 divided by delta 2 is equals to z divided by delta 3, and which is equals to minus 1 divided by what? Delta 0. So all we just have to do is to evaluate the corresponding determinants and find the values of x, y, and z. So let's begin with example 1. So for example 1 now, all we just have to do, like we did earlier, is to find the corresponding terms, all right, of a1x, a2 plus b1y plus c1, okay, plus t1z, all right, is equals to d1, and we have a2x plus b to y plus c to z. Okay, this should be plus d1 is equals to 0 plus d2 is equals to 0, and a3 is x plus b3y plus c3z plus d3 is equals to 0. And we can now perform the determinants. So for the first set, we are going to look for delta 0, delta 1, let's look for delta 2, and likewise delta 3. So let's begin for delta 0 now. Delta 0 is striking out the constants. Okay, so for delta 0 is just ABC. Okay, so all we just do is just striking out the constants. So when we are left with this, so that means delta 0 is 2, 3 minus 1, 3, 1, and 2. Okay, we're considering the whole of this. 2, 3 minus 1, 3, 1, 2, 1, 2, and minus 5 now. 1, 2, and minus 5. Now with that done, now let's try it on now and see if you can evaluate for delta 1, delta 2, and delta 3. 1, 2, and 3. Pause the video and give it a try. Now for delta 1 now, that means we are striking out x coefficients and we are left with this 9. So that means we have 3 minus 1 minus 4, 1, 2 minus 13, 2 minus 5, and 11. And for delta 2 now, that's the coefficient of y. Will be struck out, will be omitted, and we have this and this. So 2 minus 1 minus 4, 3, 2 minus 13, 1 minus 5, 11. So we have that and say this is 2 minus 1 minus 4, okay, and 3, 2 and minus 13, and likewise we have 1, 2, and 11. Nope, this should be 1. We are striking out 5. We're striking out y, so it should be 1 minus 5 and 11. Good. Now for delta 3 now, we are omitting the x coefficient, the z coefficient, sorry. So we are left with 2, 3, minus 4, and the rest. So let's couple that in that, and we have 2, 3, okay. So 3 minus 4, 3, 1, and minus 13, and then we arrive at 1, 2, with 11. So we now have delta 0, delta 1, delta 2, and delta 3. All we just have to do now is to evaluate the determinant of this. So pause the video and evaluate the determinant of delta 0, delta 1, and delta 2, and delta 3. So delta 0 will give us 23, 28. Delta 1 will give us minus 56. Delta 2 will give us 28 also. Now delta 3 will give us minus 84. Now to implement evaluating x, okay, x divided by delta 1 is equals to minus y over delta 2, which is equals to z divided by delta 3, and 1 divided by what? Delta 0. So let's now evaluate x, y, and z. X, y, and z. So evaluate x, this will be 1 over delta naught. Alright, so therefore x divided by delta 1, which is minus 56, is equals to 1 divided by delta 0, which is 28. So my x now is equals to minus 56 divided by 28. So I'm saying that x is equal to, okay, there is one thing that we omitted. this is negative 2. Remember the plus this sign, plus, minus, positive, and negative. So in that case now, we know this is negative. So divided by minus 28, or as the case may be, and then we'll have x is equals to 2. Now let's evaluate for y. Now we know that minus y divided by delta 2 is equals to 1 divided by delta 0. So my minus y divided by what? My delta 2 is 28, is equals to minus 1 divided by delta 0, delta 0, which is 28 also. Okay, so if I simplify for y now, y is equal to 1. And finally for z, we know that z is equals to, well, delta 3 is positive, okay, is equals to minus 1, okay, I forgot minus 1 again, divided by delta 0. So our z is equals to, my delta 3 here is minus 84. And minus 1 divided by this, which is 28. So therefore, if we evaluate our z here, it will be equals to what? 3. So we can come to a conclusion now that x is equals to 2, y is equals to 1, and z is equals to 3. Now we can see how short it is. Now the beauty of having determinant method is that we can just say that, oh, solve for x. We know that if we are asked to solve for x, all we just need to evaluate is just this and this. That's delta 1 and delta 0. And then we just use the expression of x divided by delta 1 is equals to minus 1 divided by delta 0. So that is the joy in using determinant method, because we can just look for a particular variable. However, in inverse method, we have to solve everything using the inverse rule. Now, to conclude this lesson, now try question 2. We want to solve 2x plus y minus 5z plus 11 is equals to 0, x minus y plus z minus 6 is equals to 0, 4x plus 2y minus 3z plus 8 is equals to 0. Now solve this using determinant method, and let's confirm our answers in the next video.